Good morning, good afternoon, good evening, ladies and gentlemen. I want to take this chance to welcome you back to my channel. I am Professor Oriaso Odongo, and my channel is Professor Oriaso Odongo's Knowledge Hub. Today, ladies and gentlemen, allow me to talk to you about the science of climate change. I know previously we have talked about climate change, the impact, legislations. We talked about many things, including the responses like mitigation and adaptation. But today I think we need to talk about the science of climate change. So in this presentation, ladies and gentlemen, I want to highlight on the process that is causing climate change. And we all know that climate change is a significant change, particularly in the parameters that we have mentioned before. We've talked about temperature, we've talked about precipitation, we've talked about air pressure, we've talked about the gases and even the winds and how all that happens. But then we also know that climate is normally the average weather condition of a place over a relatively longer time. And so if you compare it with weather, then we think about weather as a short-term climate, short-term changes that we are talking about. So then it means that climate change is long-term while weather is short-term. But then we also talked about climate change variability, and I say this is a short-term change. And then climate change is something that is longer than considered after a long period of time, say 30 years. Now, the science of climate change is what I want to measure on today. And the science of it is explaining vividly what happens. Why do we talk about climate change? And ladies and gentlemen, you will remember global warming. We've talked about it many times. But the process it takes to really occur or appear is what I want to describe. I want to start by saying that naturally, the energy that normally we receive and use on the Earth's surface is supposed to be sufficient to support all those processes. Look at the plants, look at the animals, look at all others. And this energy is actually enough to achieve what we call the normalcy, or the natural processes, and even the balance we are talking about. And within the Earth surface, we also talk about some gases that are there, naturally occurring gases. We talk about the greenhouse gases, and you can imagine we have even the carbon dioxide, as it were. We also have methane and all those. So those naturally occurring ones are actually supporting the processes that I'm talking about that causes stability. But then to a large extent, if you look at the sun's energy that I have described, much as we say that it really aids all those processes, excess of it sometimes, or the heat, that is actually existing over and above that which can be used to cause the natural processes, to a large extent is trapped. And when it is trapped, it actually supports what we are calling the normal processes, supporting the life processes. Supposing we had the sun's energy being used, all of it, with the processes we are talking about, like photosynthesis and all that, how would Earth particularly achieve even warmth? So the excess of what remains is supposed to keep the Earth warm so that we have those life processes we are talking about. Now look at that. So that is what we call the natural greenhouse effects. But I will go there shortly. Let me introduce this bit. If you look at the natural process and also you look at the human activities, we know that human activities has got capability of doing a lot, particularly exuding or releasing a lot of greenhouse gases that we have talked about. How is this happening? It happens through, let's say, this burning of coal, burning of fossil fuels, burning of oil, and even other gases. Now, when this happens, particularly from the transport sector, from the industry sector, from all this, a lot or excess carbon dioxide is exuded again into the atmosphere. To a large extent, even the methane from agricultural processes are also exuded. Now, this ensures that too much of these gases now exist on the Earth's surface, particularly in the Earth's atmosphere. Look at other processes like, let's say, deforestation. When we cut trees, we cut trees or we clear forests so that we reduce the forest cover. And I talked about something called carbon sequestration. And so then if you look at the plants, generally the trees and the vegetation cover, what they do is to be able to consume or they utilize carbon dioxide. But then in case where there is deforestation, a lot of carbon dioxide exists, so it's accumulating. So when it does accumulate, then a lot of things happen. Like we have what we are calling the thickening, the blanket-like membrane that occurs on the Earth's surface. And this membrane is what now will trap the excess heat, or the heat that is there, and then prevent it from even escaping. To a large extent, for us to have normal processes, we do have excess heat getting out of the to the other space. But in this case, it gets retained, and when it is retained, a lot happens. So then the result is huge or very high at average temperature that we're talking about. So then this is what we are calling global warming. So you probably know about that global warming. So this global warming is what normally will alter the Earth's long-term weather and climate patterns that we are talking about, hence leading to those changes that we are saying. So this is with the time, this is what causes climate change that we are talking about. Now, let me get back to that greenhouse effect I'm talking about. I wanted to have it in three ways. The first one I wanted to mention about the natural processes. I have been able to mention that the Earth's natural greenhouse effect is caused by those freely existing gases in the atmosphere, which to a large extent will trap some excess heat from the sun. And then this is what normally keeps the planet warm enough to support life. And that is a part of a natural process that ideally may not worsen and cause climate change, as it were. But then when we have the second phase, which is the human effects, the human processes I've talked about, like burning of coal, burning of oil, and burning of those gases, which will obviously lead to high concentration of those gases that you see there. And then the third bit is that bit of heat trapping. The gases that will act like the blanket that I'm talking about, which then trap those excess heat, which make it not be able to escape to the space, will cause unprecedented high heat or high concentration of these greenhouse gases. So the whole of it is what we call the greenhouse effect. Think about what happens in a greenhouse, for example. Look at the greenhouse. Many of us probably are aware of or have been able to see the greenhouse being used. Within it, there is some kind of controlled environment that we idealize with what happens in a natural process in the Earth's surface, for example. So then if we talk about, when we talk about climate change, then it ideally comes from that kind of process that I've been able to mention. And then, how do we know that climate change has happened? So what evidence exists? Scientists have done quite a lot, and what we are able to really say is that the rising temperatures that are coming from that global warming, the process I've been able to mention, has been the case. So the temperatures have been able to rise faster than at any other time in history. Look at the last 1,000 of years, and look at the more recent decades and how things have been able to be affected. We've been able to report continuous temperature rises that we are talking about. We are also able to report increased carbon dioxide levels. So we are having that high concentration, which is a result of all those activities I've mentioned, the human activities, the burning of coal, the burning of fossil fuel that we are talking about, and all this. And then we are talking about the global sea level rises. We are aware that the water bodies that we have been able to have, so many things have happened to them. That look at the waves, look at the tides, and look at that. You'll be able to go to a place where we used to just have a stream. Today, you see the stream has eaten up all the land, and have even been able to. These streams have even been able to make people to migrate to safer places. That's a signal of what probably could have taken place. So then, the causes of this climate change that we are talking about are two. The first one being the natural one. But the natural one, I'm very cautious to say that the natural one is normally actually a normal process that happens. But then it is being worsened by the second process, the human activity, what we have described as anthropogenic process, where human activity is the one that dominates. If you talk about climate change and you want to work out what has caused it, then you will find that virtually all global warmings that we have been able to report over the last 200 years or so have been because of the intensified human activities that we are talking about. And the impacts of climate change have been there, so we talk about the weather patterns. When temperature rises, particularly on the Earth's surface, a lot of things change. Like we're talking about the increasing frequency, intensity of weather events that we're talking about. Look at those weather events. The heat waves. Heat waves are there. Look at the drought, for example. Look at floods and look at tropical storms. So we are able to report across the world that these are happening. You look at also the ecosystem disruptions that we have seen, risking human life and ecosystems and the world, and quite a lot of things. So what is the role of science in climate change? What is the role of science? I've been able to give you to say that climate change is both a socioeconomic and a biophysical, and the science is behind all of it. So the explanation of how it happens is through scientific endeavors. Even in mitigation and adaptations, we look at science to be able to inform us on how to do this. For instance, science is able to help us with measuring and monitoring of carbon dioxide. How are we able to tell what amount of carbon dioxide is in the atmosphere? I've been able to previously say that at the moment we are talking today across the globe, even if we were to stop, to really stop climate change from further happening through mitigation, so we would not be out of the woods, because a lot of carbon dioxide is already in the atmosphere, and it could take so many years. So we are able to continue to monitor this, and that is work of scientists. They are able to measure and quantify what amount is there. And even the various sectors that we are talking about. In my previous presentations, I was able to explain or to really say that we can even measure the amount of accumulations of carbon dioxide per sector, and we know which sector we can blame for exuding a lot and causing climate change and global warming a lot. So science also helps us with models. So we talked about models previously. Those models are helping us with forecasting. We can forecast climate change. We can also project even the impact, even the future impact of climate change that we are talking about, and we can use the different emission scenarios that we are talking about. So ladies and gentlemen, today I was able to just give you a sneak peek of the actual process. I talked about the natural process that is naturally occurring, and I said that always the Earth has got ability to remain stable over the years, particularly if we were to look at the sun's energy as the main source of energy there, and we look at the freely existing greenhouse gases that are there, that are able to satisfy all the processes that we have. But then the excess of that is caused by human activities that will lead to excess of those greenhouse gases, which then will form a blanket around the Earth's surface, making it almost impossible for excess heat to leave to the space. And when they don't leave, that heat must really be the one that is causing the very high temperatures we are talking about. And that very high temperature is what is responsible for global warming and causing the differentials we are having and altering the climate patterns. So ladies and gentlemen, today I just wanted to talk about that, and so that we are sure that when we talk about climate change, we know what we are talking about. I want to thank you for listening, and I want to urge you not to forget about following me, about liking, about sharing, and about subscribing to this channel, because this channel has immense impact on knowledge. Remember, knowledge is one way of transformation. It is only on Professor Oriaso Odongo's Knowledge Hub. Thank you.